Hey guys, welcome to ANS Solver. Today we'll be doing the concept of integration using partial fractions, which is a subtopic in the chapter of further integration. For this concept, you need to know your partial fractions properly, which we had done in the chapter of further algebra. If you don't know it, you can go to the further algebra and you can revise those concepts. There are four types, and then you can come back here and learn this concept. So we'll be doing this concept via past paper example. This is from 2021 Feb March paper 32. Okay, so there'll be two parts in this question. The first part will be partial fractions. The second part will be integration, further integration. Okay, so basically what you need to do is here let f of x be 5a over 2x minus a into 3a minus x, where a is a positive constant. Express f of x in partial fractions. So you know that 5a over 2x minus a over 3a minus x. Okay, as you can see, the denominator is a type 1 denominator. So you can write this as a over 2x minus a, correct, plus b over 3a minus x, correct. Now you can write this as 5a equals to, you can take the LCM, so I can write this as a into, okay, 3a minus x plus b into 2x minus a, and you simply ignore the denominator as it cancels out, correct. Now what you do is you find a. So you know, for finding a, you need this full part to be equal to 0. So you simply write 2x minus a equals to 0. So you get your x as a over 2. Correct? This is what you basically get. So now you can simply substitute this and write this as 5a equals to a into 3a minus, in the place of x write a over 2 plus, I know I'll get a 0 here. Correct? That was the main motive. So now you can write this as 5a equals to, okay, a into 5 over 2a. Correct? So you get your capital A basically as 2. Correct? When you solve this. Now, I'll just remove this line here. Yeah. Now, I can simply find B. Correct? For finding B, I know this full part here needs to be equal to 0. So I can write this simply as, okay, 3a minus x, okay, which is equal to 0. So I get my x as 3a. So I can substitute this and write this as 5a equals to 0 plus b into 2 into 3a minus a. So I can write this as 5a equals to b into 6a minus a, correct. And then I can write this as 5a equals to 5a into b. So I get my capital B simply as 1. Got it? So now I can basically write it in the form as 1 over 2x minus a plus 1 over 3a minus x. Correct? I can simply write it like this. So this is what we had even done. Okay, actually this is not 1. I'm very sorry. This is 2 here. Yeah, very sorry for the silly mistake, because you basically substitute a, the place here, and you substitute b here. Correct? This is what we had done basically in partial fractions. Correct? Now the integration part of it. Okay, it's no rocket science. It's really simple. Okay, so basically you need to integrate from a to 2a and your f of x. Now I know something like this cannot be integrated directly, but we have converted it into partial fraction. So instead of the f of x, I just write this. So I write this as 2 over 2x minus a plus 1 over 3a minus x dx. Correct? So now what I can do is I can split this as the integration from a to 2a of 2 over 2x minus a dx, correct, plus I can write this as the integration of 1 over 3a minus x with the limits a and 2a dx, correct. And now I can simply make a line here. Now what I can do is I can write this as 2 into the integration from a to 2a with 1 over 2x minus a dx, correct. So now what I can do is I can write this as 2. Now what's the integration of 1 over 2x minus a? First write this as ln 2x minus a, correct. We have done this in integration p2 also. Now write this as 1, which is the pre-existing one here, divided by the differentiation of 2x minus a or the coefficient of x which you have, which is 2, correct, with an a and 2a. You can cancel the 2 and 2. So you simply get ln 2x minus a, correct, between a and 2a, correct. Now in the place of x I can put 2a first. So I simply get ln, okay, ln 2 into 2a, which is 4a, minus a, which is ln 3a, correct, minus I can put a in the place of x. So I simply get 2 into a minus a, which is a. So I simply get ln a, correct. Now I can use the log property, which states that log of a minus log of b equals to log a over b, correct. And I can simply write this as ln 3a over a, which can be written as ln 3, correct. Now I can take the other side here. Okay, so I can write this simply as the integration of ln 3a minus x, and now I know this will be divided by, okay, simply minus 1. Okay, don't get confused here because the coefficient of x is minus 1, or the simple way to remember is the differentiation of 3a minus x or the coefficient of x, which is minus 1, correct. Now you can write this as 2a to a, correct. Now what you can do is you can simply write this as minus ln 3a minus x, correct, from a to 2a. So in the place of x I can simply put 2a first. So I can write this as minus ln 3a minus 2a, which is a, minus, now I can put in the place of x I can put a. So I can write this as minus ln 3a minus a, which is 2a. So I can write this as minus ln a plus ln 2a, where I can write this as ln 2a. Okay, just give me 1 second. Yeah, okay, yeah, so I can write this as ln 2a minus ln a. Very sorry, I just thought I have made a silly mistake, but no, there's no silly mistake. So I can again use the property here, which is log a minus log b, where I can write this as ln 2a over a, which I can simply write as ln 2. Now I can write this as ln 3 with the plus sign here in the middle. So I can write plus ln 2. Now I can use the log property, which states that log of a plus log of b equals to log a into b. So I can simply write this as ln 3 multiplied by 2, which can be written as ln 6, which is what we basically needed to prove, correct. Here we needed to prove that. So basically if you see this concept, it's totally based on partial fractions, which we had done in further algebra, correct. So with this, we come to the end of the chapter of integration. It's a very important chapter. It's actually a mix of logarithm, trigonometry, differentiation, integration P2, further algebra and further integration. Correct? You need to know all your concepts and you need to be crystal clear with them. Okay, so this chapter will take you a lot of time to practice because there are numerous types of questions which they ask in the past papers. Okay, we can't obviously cover everything in the concepts. Okay, we have done the main types, but you obviously need to practice a lot in this chapter. And especially for further integration, I suggest that you do further algebra and further integration together. Okay, because in some further algebra questions, in the B part, they ask you further integration, like something like this. Okay, the A part will be, let's say, partial fractions, which is further algebra, and the B part will be integration, further integration. Okay, so it's better if you do it together, or you can do it separate also, or you can solve it while you are doing full length past papers. Anyways, you need to practice a lot for this chapter. It's not an easy chapter. It needs a lot of practice to master. And even if you get stuck while solving, we provide video solutions. You can view them, clear your concepts, and get a full mastery of this chapter. So thank you very much for watching.